I'm going to go over exam number 3. Let's get started. Number 1, I have a building. The two person start moving to the west, right? Okay, with constant velocity 4 meters per second, spending only 1 second, right? One person ended up, the blue person ended up right here. However, the green person ended up right over here. I'm going to start my conversation with d is equal to dx is equal to vix t plus half ax t square, and dy is equal to viy t plus half ay t square. Now let's first start with the blue person. The blue person ended up over here. Okay, so I'm going to find it for blue person. I can do it two way. Okay, I can do it this way and I can do it by geometry. So I'm going to use both. So the displacement or dx should be vix is 4 and t is 1 plus half. What would be his acceleration, right? At the x direction. Well, x direction, his acceleration is 0 because he was moving at constant velocity 4 meters per second. What would be his acceleration at the y direction? Well, his y direction, the acceleration of his y direction, this guy, acceleration of the y direction for the blue guy is also 0 because he was not falling. Okay, so 0 t square. So dx is equal to -4, and since I asked you to give me the magnitude, so magnitude of -4 is 4 meters. We can do the same thing using VT graph, right? Okay, since he is moving with constant velocity, what does that mean? That means he is moving with -4 meter per second, right? How long did he move? 1 second. So I have area, and that's what I asked you to find. Area is equal to BH because this is a rectangle. Area has a name, displacement. B is 1, H is -4, so displacement is -4 meter. I ask you to find the magnitude of the displacement. Find the magnitude of the displacement. When you find the magnitude, when you take the magnitude of the displacement, you get the distance. Okay, so the blue guy moved how long? 4 meters. Okay, so the blue guy moved 4 meters. 4 meters from east to the west. Okay, now we're going to find how tall is the building. So that's we're going to find using another equation. We're going to use this equation. Okay, so dy is equal to, remember this is the displacement, so this is a vector quantity, viy. Right here you have v is equal to vx and vy. Vy is 0, right? Vx is, of course, we already know that 4 meters per second, right? Vx is 4 meters per second, but we do not, okay, so there is no Vx component over here. So Vy and Vy is 0. Half. Ay is -10, t is 4 square. So dy is equal to -80 meters. We want to find the height, okay? We want to find the magnitude of -80. So the magnitude of -80 is 80 meters. So this is problem number 1. Now let's do problem number 2. All right, to the east, right? I give you 3 location, T1. I give you a few things. I give you a position function, right? And that is a 15t. And 15t position function. So let's see how the position function look like. Right, position function would look like a straight line, right, or a diagonal line, whatever you like to call it. That's the position function. If you take what is the slope of dt graph? The slope of dt graph is the velocity. So how the velocity should look like? The velocity should look like a horizontal line above the x-axis, because if you take the slope, this is how it's going to look like. We're going to call it velocity. What about the acceleration? Acceleration versus time graph, right? Acceleration versus time. Now, slope of this one would be 0. If you take the slope of, slope of this line, that would be 0. So let's make it obvious. Okay, so acceleration is 0. The slope of dt graph is velocity. The slope of velocity versus time is acceleration, and acceleration is 0. So let's write acceleration is 0. Okay, few other things. Time initial is 0. Time final is 2. Distance initial is 0. Distance 2 is 20, and distance final. Okay, now if you put 2 over here, if you put 2 instead of t, if you put 2 over here, then you get 30. So distance final is 30, right? What is t2? T2 is, all right, p of 2 is equal to 15t, right? Okay, I want to find the time when distance is 20, right? When distance is 20, then the time is 20 over 15. Time is 20 over 15. Okay, 20 over 15 is 1.3. Okay, good. Now velocity, let's find the velocity. We know few things. We know our area. Area has a name. This is the area. Okay, this is area. Area is, this is a rectangle, so BH. In physics, there is a name for this area, and we call it displacement. Base is time, and how long? The time is 2. Okay, all right. And what is the area? Okay, we'll talk about it. And then h is the velocity. The displacement is 30 when time is 2 hours. So velocity is 15. So velocity is 15. Since the velocity is a horizontal line, okay, and since the acceleration is 0, you cannot change the velocity when the acceleration is 0. Not possible. Next question I ask you, what is the average velocity? Average velocity has two equations. One is vi plus bf over 2, and other one is df minus di over tf minus ti. df is 30, di is 0, tf is 2, 0, which is 15. Okay, average velocity is also 15. Now, did the person break the law right here? No. Why? Because 15 is less than 25. So the man never did break the law, and that was problem number 2. Okay, so the problem number 3, you drop something from 100-meter tall building. Displacement, distance, velocity, speed, and acceleration due to gravity. Acceleration due to gravity is always -10 because it's constant. Okay, why is that? Because if you draw AT graph, let's draw dt, vt, and AT graph. So dt, vt, and AT. So this is displacement versus time, this is velocity versus time, and this is acceleration versus time. So the dt graph gonna look like this, vt graph gonna look like this, and AT graph gonna look like this. So this has to be -10, right? Okay, so the -10 come from here. So velocity initial has to be 0, and that makes sense. Velocity initial is 0, 0, 0. At time 0, okay, what is the displacement? Is 0, distance is 0, velocity is 0, speed is 0, everything is 0. Now, end of 2 seconds, object displacement how much? Object displacement is -5, distance is 5, velocity is -10, and speed is 10. How do I know at the end of 2 seconds is, no, not -5. At the end of 2 seconds is, Okay, so at the end of 2 seconds, object displacement. So let's see, d is equal to vat plus half at squared. At the end of 2 seconds, at the end of 2 seconds means you put over here 4 and you put negative 10 over here and half. Okay, vat is 0. Okay, what is the displacement at the end of 2 seconds? So at the end of 2 seconds, object displacement is negative 20. So distance is 20. Velocity is at the end of 2 seconds, velocity is vf is equal to vi plus at, right? Vs is equal to this is 0, this is negative 10. At the end of 2 seconds is negative 20. So speed has to be 20, right? Okay, now 80, right? At the end of 80, so d is equal to vat plus half at square, right? At the end of 80, so you have 80 over here, you have vat is 0, you have minus 5, what do you have? T squared, right? So now 5 goes to 80, 16, so 4, this has to be 4 seconds, so this is negative 80. So at the end of 4 seconds, you have to have velocity which is negative 40, and this is 40. Okay, why negative 40? Because vf is equal to vi plus at, right? This is 0, so this is negative 10 and then 4 at the end of 4 seconds. At the end of 4 seconds, velocity is negative 40. You throw an object upward with how much? With some velocity. Let's say velocity initial is 20 meter per second. What is t initial? T initial must be 0. What is t2? What is v2? V2 must be 0. What is t3? What is v3? V3 must be negative 20, right? Okay. T3 we don't know. Let's find T3. Vf is equal to Vi plus Gt minus 10t. So you have negative 40 is equal to negative 10t. So time over here is 4. Then time over here is 2. Okay, good. This is your dt graph. So if you do the Vt graph, then it should look like this, right? So this is your 20, this is your 2, and this is your negative 20, and this is your 4, right? So this one would be how much? This one would be half b, which is 2, so 2, and h, which should be 20. 2 to cancel, so this is 20, this is 20, and this is negative 20. Okay, so your displacement would be d1 plus d2. d1 is 20 and d2 is negative 20. Okay, all right, so now let's complete it. What is your velocity initial? Velocity initial is 20, 20, 20. Okay, displacement when time is 0, 0, distance 0, velocity 20, speed 20, acceleration negative 10. The time when velocity is 0, 2. When velocity is 0, the time is 2. Displacement, we already found the displacement. The displacement is 20. Distance is 20. Speed is, we already found the speed. Speed is the absolute value of this one. The speed is 0. Acceleration is negative 10. Acceleration is negative 10. Okay, the time when velocity is negative 20. When velocity is negative 20, time is 4. Displacement is this one plus this one. This one is 20, this one is negative 20. So displacement is 0 when time is 4. Okay, because the ball or the marker in this case return to the same location. Distance is 20 plus 20, which is 40. So distance is absolute value of displacement 1 plus absolute value of displacement 2. So 20 plus 20. So distance is 40 and speed is 20. Okay, so that one was problem number 4. So a ball, okay, down from 20 meter above the ground with negative 4 meter per second. And I wanted to find few things. So let's draw the graph dt, vt, and at. So the dt, vt, and at. right? Okay, so this is displacement versus time, velocity versus time, and acceleration versus time. Okay, so what do you know about this one? Displacement versus time. I'm gonna write it like that. This is displacement versus time. Velocity versus time, I'm gonna call it like that. And acceleration versus time, I'm gonna do like this. And you know this is -4. Good. Okay, I want to also find the time, the final time. So d is equal to VAT plus half AT square, right? So total displacement, if I put the total displacement over here, I definitely can find the time. So -20 is equal to VI -4 t minus 5 t squared. So you have 5t squared plus 4t minus 20 is equal to 0. Okay, so now you have minus b plus minus b squared minus 4ac over 2a. Your b is 4 minus 4 and then plus minus 16 minus 4, a is 5 and c is -20. So you have 416 for 1.64. So your time is 1.64. Okay, so this is 1.64, right? So it does fall 1.64. Your final velocity. What would be your final velocity? Let's see what is your final velocity. Your final velocity would be velocity initial plus AT. Velocity initial is -4 minus 10, 1.64. Okay, so -4, you have 16.4, right? So you have 20.4, -20.4. Your final velocity is -20.4. So -20.4. Okay, so it seems like we know now everything. When the displacement is 0, velocity initially is -4. Okay, time is 0 when the displacement is 0. Distance is 0. Velocity is -4. Speed is 4. This is -10. This is -10. This is -10. Okay. All right. When the time is 1, what is the displacement? Okay. Let's find out when time is 1. What is the displacement? You can do the VT graph. VT, right? Okay. This is -4. All right, like this. And the time is 1, right? Okay, all right. When time is 1, what is the final velocity? Time is 1, where final velocity is BF is equal to VI plus GT. So this is -4, -10, and 1. So -14. This is -14. Okay, so this is BH. So -4 times 1 is -4. This is half BH. So half negative. The time is 1, right? Time is 1, and then h is -10. So -5. So -5, -4 is -9. Okay. So displacement is -9. Distance is 9. Velocity. At the end of 1 second, velocity, we saw that velocity is -14. Okay, speed is 14. Okay, distance at the end of what do you call it? At the end of 1.64 second. Okay, let's see displacement at the end of. So this is -4, this is 14, right? This is no, this is 20, -20.4, -20.4, right? And this is 1.64. Okay, so I have 4 times 1.64, and I have 1.64, 20. So okay, so the total distance is 20. Okay, speed is 20.4. Okay, so that was the problem number 5. Now we're going to do problem number 6. and he moves velocity 1 is 40 mile per hour, and then he immediately moves from B to A, and turnaround time would be 0 second. Okay, and that his velocity too is 60 mile per hour, right? I want you to do the 4 graphs, graph 1, graph 2, graph 3, and graph 4, and you're going to call it displacement versus time, velocity versus time, distance versus time, speed versus time. Okay, so let's do let's make it green. This one, let's make it green. Okay, green car. Okay, the green car moving to the west, so that is from distance 0. Okay, move to the west for how long? 2.5. How do I know 2.5? 2.5. How do I know it is 2.5? 2.5 is equal to distance time 1 is equal to distance 1 velocity 1. Distance 100, velocity 1 is 40. 0 0 cancel, so it's 10 divided by 4 is 2.5. Okay, now we're going to do distance 2. Distance 2 is this one, right? And how long it takes? Okay, so T2 is 100 divided by 60. 0 0 cancel, 10 over 6. So the other one is 2.5. 10 over 6 is 1.7. 1.7. So this is 4.2. So this is 4.2, and this is of course negative 100. Good. Now, okay, now we're going to take the slope of this one. Slope of this one would be this, and we're going to take the slope of this one. Slope of this one. Slope of this one would be this. Okay, so then what would be the coordinate? This would be negative 40, and this would be 60. Okay, and this is 4.2, of course. All right, now let's take the absolute value of this one. Absolute value of this one would be this, and absolute value of this one would be this. What is this one? 100. What is this one? 200. What is this one? 2.5, and this is 4.2. Absolute value of slope of this one would be this, and slope of this one would be this. Okay, this is 40, this is 60, 2.5, and 4.2. Okay, so this was the tutorial for exam number 3. If you have any questions, please let me know in the class tomorrow.